Hello class, let's build a circuit to study Kirchoff's voltage law. Let's add the DC voltage source first. Next, let's add 3 resistors in series. Let's use the copy feature to add the last resistor. Now let's connect our components. Let's not forget to add our ground. We'll change the values of each component next. Now let's add some voltage and voltage reference probes to measure the voltage across each resistors. Pay close attention to where I am placing the probes. Clicking the V- will give you a voltage reference probe for the respective voltage probe. PR1 will measure the voltage drop across R1, PR2 will measure the voltage drop across R2, and PR3 will measure the voltage drop across R3. We'll add a current probe as well, to measure the current in the circuit. Now let's simulate our circuit. Let's study Kirchoff's voltage law first. Kirchoff's voltage law states that the algebraic sum of the potential differences in any loop must be equal to 0. In other words, if you travel around any loop in a circuit, the voltages across the elements add up to 0. To begin, let's make the general assumption that current is flowing from positive to negative. Therefore, for this circuit, the current will be flowing clockwise around the circuit. Now let's add the polarities of each element. For the voltage source, the short line of the voltage source symbol is always negative, and the long line is always positive. Now, take a look at the polarities of the resistors. Since we are expecting the voltage drop, or in other words, the voltage to be reduced across each resistor, and we made the assumption that current flows from negative to positive, this is the reason why you see the positive sign first for each resistor. Starting at the ground, and going clockwise around the circuit, let's add the voltages. Remember we made the assumption that current flows negative to positive. Which means that when the current enters the negative terminal first of a component we add the voltage, and when it enters the positive terminal first we subtract the voltage. By doing this, you can see that the sum of the voltages around a closed loop equals 0. Like said before, Kirchoff's voltage law can be performed around any closed loop as long as you apply the correct polarities for each component. Let's consider the outer loop of this circuit. Let's add back the polarities of each component. Again, if we start at ground and go around the outer loop of the circuit, the sum of the voltages equals 0. Let's explore the lower loop, for it has the same resistor values as the previous example. Because we added another resistor R4 to the circuit, the voltage drops across R1, R2, and R3 are not going to be the same as the previous example. However, Kirchoff's voltage law still holds true. If we start at ground and add the voltages in the lower loop, the sum still equals 0. That concludes this video. If you like what you see and learned something, please like this video and subscribe to the channel. Comment below any questions you may have or suggestions for other videos. Thank you.